What is capital? In this slide, we review together what is capital. And you may say, I already know what is capital, and that's correct. But let me tell you this. I believe in, at least in most of the cases, I believe in training that start holistically. It starts from core concepts, it starts from fundamentals, and after that it goes to details, definitions, or that type of thing. Because otherwise I believe training would become dull. So the reason that at the beginning of this course we didn't review the exact definition of the terms that we use a lot in this course, because I didn't want to get any learning energy from the students to be directed to that direction. As I said, I want the students fully focus on the core concepts, on the fundamentals. And after that, when you get that foundation, and after that, that polishing, that reviewing the exact definitions, not only is not boring anymore, but it is refreshing. So that's the logic, that now we have the definition of capital, while we have done many examples about capital investment and that type of thing. Okay, what is capital? Capital is the initial money invested to acquire an asset, like a machine, like an equipment, or installing a system. Usually, capital is paid upfront and tied up for several years until it is recovered completely. Now, the next technical word that from now on you need to know the exact definition of is capital recovery. When you look at capital recovery intuitively, you may come up with the definition of that word. And I should tell you, it is a well-established technical terms in the field of financial management, capital budgeting, or engineering economy. And it is related to capital on one side, and on the other side it is related to annual amount required to recover that initial capital investment. So it is not a new thing. You have already done many examples over them, but now we are emphasizing on the definition. And it's another proof on the fact that now it is for a while that we are not learning together any new formula, any new function. It is just about polishing what we have learned with better management strategy, structure of the things that we already know, just to increase the productivity of our financial analysis knowledge, financial management knowledge. So if I consider this capital investment, capital recovery is the equivalent of, this is the equivalent of this initial investment in an annual form, my friends. that annual thing is critical here. And again, it is not something that we are handling for the first time. We have done many examples that were focused on capital recovery, just we didn't emphasize the technical word. And I told you why now. So here, when we go for more polished definitions, we have here the equivalent annual amount required to recover the initial capital investment over the asset's life, considering the time value of money. You may ask, what about the salvage money? Yes, we consider the salvage money as well. So it is totally a technical and acceptable, theoretically approved technique in our calculation. Capital recovery converts an upfront investment into an equivalent annual capital cost. You see, just different definitions. Another one. It answered this question. If I spread the initial investment evenly, so that again annual, over time, how much capital do I recover per year? And here we have an example. If the project duration is 1, capital recovery, that annual equivalent, is 8,100. If the project life is 2 years, the capital recovery is 4,206, and like that it comes down. And you remember we talked about this thing about minimum cost life. It always gets down. For example, if you have a machine and something bad happened to that machine, that after 1 year it is done, or after 2 years it is done, or after 3 years it is done, most probably the capital recovery would be a high payment, would be expensive. So that's the reason in the initial years of using a machine, risk is high, because if anything happens, maybe it turns a profitable project into a failure. But if you are considering that project in your calculation for example, 7 years, you get to that 7 years and still it goes very well until, for example, year 15. Here you are making a lot of money. Why? Because the capital recovery is become smaller and smaller. So that's the reason you see in some investors intentions to be pro-defender, to keep the current machine or alternative they have. Okay, now we do an example, and since it is a descriptive type of example, and I'm sure it's not going to be a challenge for you to understand this, so I'm quickly jump to the answer also. So we are going to review this minimum cost life of a new asset, capital recovery. Now you see the main point of knowing the exact term, because when you say here it says capital recovery, you quickly get what does it mean. Year 1, 8,100. Year 2, 4,206. And capital recovery, as I told you, if it goes to 15 years, it becomes cheaper and cheaper. So it says in year 1, capital recovery. And what does it mean in year 1? If the project lasts for 1 year. And the salvage value will be considered here. Year 1, if the project life is 1 year, the capital recovery 8,100. EUAC maintenance, everything should be EUAC, because we want to come up with the minimum cost life, and minimum cost life is the number of years in which EUAC is minimum. Operating cost 500, and what is EUAC total? Summation of all these things, 8100 plus 0 plus 500, that is 8600. What if the project works for 2 years? Capital recovery becomes almost half. Maintenance increases from 0 to 433. The operating cost increases, but still the total EUAC decreases. So 4206 plus 433 plus 692 equals 5331. So it continues that thing because it wants to find the minimum cost life. Minimum cost life is go for EUAC total, that is minimum. So we go here and check, comes down from year 2 to year 3, again goes down. From year 3 to year 4, again goes down. From year 4 to 5, it goes up. So this is the best time. And you have noticed that many people have their rules. For example, there are some people who only buy brand new cars and they sell them, for example, after exactly 5 years, after 4 years. They have come up with some numbers after many experiences. Or we have people who only buy the cars who are 2 years old or 3 years old, and they sell them after 5 or 6, and they all are excellent real life examples that you can start working on and benefit from the insight you are getting. For example, just now, if you are considering replacement of something that you have, if it is an electronic device, or if it is your car, or if it is your house, anything. Now please do it with everything you learned in this course. And you will notice that how much more you will learn during that real life personal exercise you are doing. And it's very interesting that you can apply this model to anything that you are considering replacement. There is always capital recovery. There is always maintenance. There is always operating costs. And there are also something else. And here it shows that if maintenance and operating costs increase, even decrease in capital recovery cannot save and guarantee decline of EUAC total. And at one point it starts to go up. And that's the reason the companies who are very careful about the financial situation keep track of all the things carefully. Here you see visualization of what you just saw in the previous slide, and what we need is EUAC, and you see the behavior of a EUAC over different years, and it is minimum over here, that is about 4